is up, everybody? How's it going? How is it going? Akansha, how you doing? How's Civo Navigate? How was Civo Navigate?
Oh, it was great. Like it was my first time attending Navigate, so I met a lot of people whom I was interacting with on over Twitter, and also the community was amazing. So like a lot of passionate folks to talk about tech. So, but yeah, right now I'm dealing a lot with the jet lag. So
Yeah, I totally.
it's
You
pretty
you
bad.
you did a talk. You did a talk there, right?
Yeah, so I talked about unconscious bias, which happens in technical communities, and a lot of people came up for my talk, so it was great. I got a great feedback, and yeah, so this was nice.
Fantastic. I love it. I was there too. I mean, we got to have
Mhm.
dinner. I did a talk with Kat Morgan, who's from Pulumi, but she's currently not in the stream at the moment. She'll be on other streams, so you're welcome to come hang out if you're watching. But we talked about IAC and networking, and we did talk about BGP, Dan. So we're covered there. Leon, what have you been up to lately? You've been we haven't really been in contact in a bit, so I want to know what's up.
Yeah, last week was like prepping for Pune first. So I went for this event called Pune first. So I had like a small hardware booth. So I was just prepping for that and just the usual work. Uh, Going for another conference on like 29th. So I have to book flights and
Awesome.
Nice.
And Dan, what is up with you, man? Tell me a little bit about what's going on in your little space there in the world of eBPF and DHCP and HTTP and all that magic in between.
In my spare time, I've always wanted to learn eBPF. I mean, it's kind of given the Cilium angle to things, and everything is all based on eBPF. Like I've wanted to learn it, and there's been kind of lots of voices of almost kind of eBPF can do like this small amount of stuff, and kind of it can't really be used for a lot of other things. So I've been like, well, I don't know if that's true or not. So I've basically spent a lot of time trying to work out what I can kind of fit into eBPF. From a networking perspective, I mean, there's a lot more other angles to eBPF. It hooks into everything. But yeah, from a basic perspective, most people, when they think about eBPF and networking, they largely just think about it kind of wrangling sources and destinations and maybe doing some natting, but largely kind of, taking a packet and sending it to one of a few backends, so load balancing effectively. But I've been wanting to do kind of the layer 7 stuff. So actually, not the IP headers, not just the TCP or UDP, but actually what's inside the packet itself. So I've been kind of writing a bunch of parsers to be able to kind of read the actual data itself and then implement some logic about that. So HTTP protocol, being able to look at kind of paths that are being requested and potentially block it or redirect it somewhere else. So if I see somebody kind of trying to do one of the file system things where they're trying to get like EDC password as part of the URL, block that, things like that. DNS requests, being able to patch BGP routes on the fly, so being able to understand the BGP protocol. And then this weekend, I've largely, this is how exciting my weekends are. I've been writing effectively DHCP server inside of eBPF. So something will start, it will do a DHCP request. eBPF will see that packet on the wire and it will take that packet and turn it into a DHCP response and then send it back to whatever's asking it. Then you'll send an offer, you'll get the request, and then you'll get the ACK back and things like that. And that has been a long-winded, somewhat miserable experience so far, but I'm kind of nearly there. The end goal for this really is I'd like to actually see if I can get a bare metal server bootstrapped in eBPF. So that's how exciting my weekends are anyway.
I love it. So let me ask you though, on the outside of this, let's just say someone was a consumer or end user, how would they stand to benefit from some of the work that you're potentially looking to put together? I mean, I know you're doing this out of just for fun and whatnot, but if someone were to say, hey, I think there's some legs for usage in production, tell us a little bit about that use case.
Yeah, I mean, there's a bunch of different areas where you could kind of take the viable, kind of what I've tried to do and turn it into something that would actually be beneficial. So always observability, being able to see what routes are flying around, what DHCP requests are being made and how long they take, and potentially change that, or patching systems on the fly, for instance, based upon behavior and stuff like that. For instance, we see routes being advertised and we know those routes are now wrong. A BGP program could basically be attached that will patch those routes on the fly and things like that. So we can observe everything that's actually taking place from a networking perspective, deep within the actual application layer itself. We can get observability in there. We can see what people are asking for based upon various protocols. We can get kind of latency issues on there, errors. Really, what I'm kind of finding is that the options are kind of a bit limitless, really. It's like, as I start to play with stuff, I'm like, ooh, that's a good idea, I'll do that. And then, ooh, maybe I could do this. And then my weekend disappears because I've sat reading old protocols and looking at Wireshark diagrams and things like that.
That's fun. I love that, because it just really just allows us to, dig even deeper into some of the capabilities that eBPF can extend to us from a networking standpoint. Like you're talking about rewriting routes for BGP on the fly in BGP. And, to a lot of folks, like thinking about this from a network engineering standpoint, that seems dangerous, because like you wouldn't want links and networks to be flapping and route propagations to be happening consistently. But then on the flip side of this, sometimes this does create some efficiencies in the way we process packet flows and traffic flows. So I'm happy to see the other end of this once you get closer and closer. So
I think one other good example really is, I can't remember his name, Marcus something or other, but he discovered one of the big spyware botnet things that was happening on everybody's machines and things like that. And the fix for that was to black hole a DNS record or something or other, which would stop the spyware being able to speak back to the mothership and things like that. All of that sort of stuff we could really easily do in BGP, where all of a sudden we realize that, things are trying to reach out to some external site to get this, that, and the other, or Bitcoin miners or anything like that. We could quite easily do eBPF programs that would just basically stop that behavior dead.
I love that. Yeah. And it doesn't have to happen specifically in user space. That's the beautiful thing about it.
Yeah. User wouldn't even need to know, really.
Yeah. So that's awesome. All right. So we're going to dig into some more network policy. And that's primarily because, I feel like we touched on it that first time and we did a very simple policy. I know we looked at network policy editor. Let's go back and look at network policy editor, because I think it's important to understand the different ways you can construct a policy, the different fields, the structure of that configuration or that CR, either if it's a Kubernetes native CR or if it's a Cilium CR. And CR, for the folks that are not aware, stands for custom resource or custom resource definition. So having said that, let me go ahead and share my screen. I'm trying to create a GKE based cluster at the moment. So you might see me do some things behind the scene, but that's all good, because I effectively just want to be able to have a cluster to test something later on if I really want to, that is much more resemblant of something production grade. All right, so network policy editor. This seems like a little bit of a learning tool, right, Dan? Like in a lot of ways, it helps us visualize and understand how we would go about forming a network policy and different pieces. Yeah,
precisely that. Really, I think without something like this, you are largely kind of just more YAML, and it's hard to visualize when staring at just a bunch of YAML in terms of what the rules you're implying, what that would actually look like within the cluster itself. So the UI and network policy kind of makes it kind of quite easy if you say, like inside the cluster, this namespace and this service and blah, 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 blah. And you can see, kind of how it joins up and things like that.
Yeah, no, this is fantastic. So I guess we could, I'll read this stuff to y'all and I'll read it to the audience, because I feel like it also helps me reaffirm my own understanding at times too. Because right now I'm just hearing a bunch of text and I'm not even sure where to begin. So it is welcoming us to the network policy editor. And in this tutorial, it'll teach us how to create a network policy using the editor. So I love that it explains some of the basic concepts and then the ways we can achieve least privilege. So back in the firewall days, in order to achieve that concept of least privilege, you would actually deploy a denial policy. It's the implicit default denial, which is a catch-all. If you don't have a policy ahead of that, because rules are read top to bottom, you don't have a policy ahead of that that says allow this, then all traffic will be blocked, right? So one of the cool things that we could do with Kubernetes network policy or even Cilium network policy is create that default denial. So step one, what pods do we want to secure? First, select the pods to which the policy should be applied by matching pod labels. A network policy can be applied to an individual pod, a group of pods, an entire namespace, or an entire cluster. So we can get as specific as the individual pod. Let's just say we've downloaded one very highly, important, highly critical workload into our Kubernetes environment. We don't want anything to touch it. We don't want anything to communicate with it except for maybe a few endpoints. And we could create a policy to narrow that down to that specific pod. Or we can go a little bit, higher level and do this at the namespace level if we wanted to, or at the cluster level. So I like that flexibility. And I'm curious, Dan, is this something that is, so the granularity piece, is that something that is specific to Kubernetes network policy, or is that Cilium network policy?
For this is the Kubernetes networking policy. So the granularity for pods and selectors and things like that, that is within Kubernetes. The Cilium network policy is basically just that plus. We're being able to do a lot more because we control the actual networking stack and things like that. We can do more stuff. Kubernetes network policy effectively applies to what happens with kubeproxy. Cilium network policy is kubeproxy plus eBPF in the CNI and stuff like that. So you can start to see that we can affect behaviors after the Kubernetes cluster has done its bits and things like that. That's probably the best way to think about it.
I love it. Awesome. Okay. And then there's a note here. If the pod selector is left empty, the policy will be applied to all pods in the namespace. So if we're looking at this Kubernetes network policy for a second, we know it's Kubernetes native because of the CR backend. We know it's a network policy type, and there's a very generic name, which we could probably change. I can't edit in here. I have to edit it somewhere else. That's fine. And then here, the pod selector. So it's empty, meaning all pods in the default namespace, because we haven't specified a namespace here, are going to have this policy applied to those pods. So what it's telling us to do is to specify the pod selector, policy name, and namespace. So it's called untitled policy. So maybe we give it a name. We'll call it my policy. I'll be honest. Okay. Dan laughed because in production, you obviously don't want to call it my policy. You want to have it as specific as you possibly can, because guess what? When someone else on the other end is troubleshooting an issue and they just see my policy 50 times over in different environments, that means nothing to them, right? So
I mean, you could version control it and have it my policy 1. Then you'd have my
too.
policy 2 to however. There we go.
There we go. My policy V1. All right. And then we'll call it, I don't know, Star Wars for now. Not Star Wars, Star Wars. All right. And then we'll use these same app equals front end and env equals production. Front end, and env equals production. So the moment I save this actually will update this network policy here. So let's look at this for a second. We have a new network policy, and it's called My Policy V1 in the Star Wars namespace. And the pod selectors are effectively matching front end and production. So any pod with these labels, let me ask you a question. Is this a union, or is this either or? Meaning, can I just have one of these labels and not both to be able to have this policy applied?
I believe it's either or.
Okay. So let me ask you this, is there a mechanism to enforce that both of these labels need to be there on the workload?
Not sure.
That's a good question to look in. We can look into it, but it's something to think about. Now, if you notice the difference between the two network policy structures, right? One is just a Cilium network policy, and it's called out that way, and it even maps to the Cilium.io API. But if you also notice the spec here, it calls it an endpoint selector, because what Cilium views like pods or workloads as endpoints, and they've associated an endpoint ID to each one of those pods, right? So yes, there is a lot of resemblance to the Kubernetes network policy resource, but in reality, this is allowing us to be able to leverage some of that eBPF magic under the hood, and leverage the endpoint IDs to make decisions on those endpoint IDs, irrespective of what we're seeing in just Kubernetes. So step 2, introduce an ingress and egress default deny posture. So the standard network security posture of Kubernetes allows all network traffic, and we're responsible for restricting all communication by introducing a default deny posture. So this is what I was talking about earlier on. We need a default deny all that catches just everything for the moment, which means it effectively blocks all traffic. And this could be within a namespace. This could be across namespaces. This could be, this could be applied in any direction until we start to open this up a little bit more, right? So it says right here, this can be done incrementally. That is, you can place individual pods or group of pods or entire namespaces into a default deny posture, or you can tackle ingress and egress communications separately. An empty policy with only a pod selector does not enforce any rules. By adding a rule, even an empty rule, the selected pods will change into a default deny posture. So with no rules, there's no policy. There's effectively nothing going on. There's no blockage. Traffic will continue to move forward. But the moment you apply some sort of empty rule, that's the default denial. So what we're going to do is we're going to enable a default deny for both ingress and egress. So the moment I selected that, the ingress one shows up here. And you can even see in the ingress field here, there's nothing there. So this applies to everything at the moment, in the sense of all traffic coming inbound is going to be blocked. Same thing outbound. Traffic leaving this environment right here based off of these labels will also be blocked. All right. So the next step is telling us to allow traffic to Kubernetes DNS. Now we're incrementally going to add on top of our default denial at the moment. So the pods will likely want to resolve DNS queries on port 53 UDP. Yeah, this is entirely true. Like if I've got a pod resources that's a set of pods that are communicating with an external resource, and they need to just capture some information, they first need to resolve that resource because they need to know how to route to them. But if DNS is not present, if there's no DNS resolution present, because obviously we can't make a call out to the DNS server because port 53 is blocked, well, the resolution is not going to happen and the connectivity is broken. In fact, this is like a problem that happens so often in data center environments, cloud environments, any kind of environment that you could think of, that we just tend to overlook this very, very simple thing. So yes, if for whatever reason there might be network connectivity issues, it could be DNS and it could be a port being blocked, UDP port 53 to be exact. All right, so we're going to allow egress traffic to Kubernetes DNS. So what this does, this just added a whole bunch of stuff here. So this is an egress rule, which is saying to the endpoints which match these labels, right? io.kubernetes.pod.namespace kubesystem. So the resource must be in this namespace, and the app itself must be kubedns. Is it kubedns? Isn't it core DNS now? Or do they still call it kubedns as a label?
I guess the label must have stayed the same.
It's fine.
They might have tried to find out.
Yeah. And then, so this is basically saying anything going towards this, and then specifically to port 53 and specifically with the UDP protocol. And remember, there's TCP and UDP communications. TCP is connection oriented, meaning when I make a communication out to something, I need an acknowledgement that my communication stream made it out there. In the case of UDP, that's not necessarily the case. I would just fire traffic away and make sure that it arrives, and I hope for a response. So that's where we're using UDP or user datagram protocol here for DNS. And then we have a rule here that says DNS. And then there's this match pattern field, which
So
there's an
wait, I
asterisk.
have one question.
Yeah, sure. What's up?
The difference between core DNS and kube DNS?
So I think the difference is implementations. I think kubedns came before core DNS. Is that right, Dan?
Yes, there used to be a different DNS service, basically.
Yeah, that was native to Kubernetes. Basically, the way something like core DNS is supposed to work is the Kubernetes API just effectively updates a host file and makes changes to that host file anytime resources go off and on and whatnot. I mean, it's a lot more detailed than that, but simply what we're doing with core DNS is there's a file that core DNS owns, and then that file gets updated every time a pod comes on and comes off, or a service gets instantiated inside of Kubernetes, and the Kubernetes API is controlling that. It's a lot more specific than that. Obviously, we could definitely spend a session talking about how DNS works inside of Kubernetes. We'll save that for another time.
It's quite a big topic. Yeah, so the label on the replica set for core DNS, it has the labels Kate's app, kube DNS.
Got it. Yeah. Okay. So help me understand this match pattern thing here. So there's this rules DNS, and then there's this match pattern with an asterisk, which is normally indicative of a wildcard or kind of a catch-all. So is that match pattern supposed to indicate we're going to any external DNS server or anything that resembles DNS within the cluster?
Yeah, I'm just double checking because I don't know if that is a rule that's specific, that is allowing or defining DNS specific rules. So what it's actually allowed to look up and things like that.
Well, interesting. Inside of the Kubernetes network policy, it's a little different. This is where it starts to deviate from Cilium network policy because it's not there. Yeah.
So let me just quickly find out for you.
That's fine. So we'll keep moving forward.
Specific policies. So with Cilium network policy, we have specific DNS rules. And
okay.
So, for instance, you could have the pattern asterisk.github.com, which would allow us to do any lookups and things like that. So,
interesting.
Because we've got eBPF, we can actually understand DNS requests, and we can, this is where the Cilium network policy starts to things to the next level, because we can now understand application-specific behaviors and things like that.
Okay, that's pretty cool. Okay. So now folks are noticing, or should be noticing, the deviation and the difference between how Kubernetes network policy handles it, and then where the additional granularity starts to show up with Cilium network policy. And this is important because when you start to begin to evaluate workload systems or orchestration systems, Kubernetes is one, but there's so many out there. You have to also think about what you need on top of that. Kubernetes by default doesn't offer network policy out of the box, in the sense of it'll action it for you. You still need a CNI plugin to make that possible, and one that actually supports that resource. But here's the interesting thing: it's a just enough approach. But once you start to hit critical mass and go into this realms of production and scale, the Kubernetes network policy is only going to take you so far. So Cilium network policy is really where that scale comes in and shines, because now you're able to slice up your policy in different ways for the different kinds of workloads that you run. And with that match pattern here, you can get very, very specific around where you're routing to your requests to. So I love that.
Yeah, it's quite funny because, I mean, I think a lot of people just presume that network policies is something that just kind of, well, with a lot of things, it just kind of comes out of the box with kind of Kubernetes. But people wanted to use network policies as their clusters matured and things like that. And you ended up with like weird amalgamations of, so Flannel, people ran Flannel everywhere. It's still in a number of places, but Flannel doesn't support network policies. So a lot of people ended up with this, kind of weird blending of half of Calico and half of Flannel. And you ended up with a thing called Canal, where you would have Flannel doing traffic in and out of your hosts itself. And then you would have just enough of Calico doing the network policy side of things. And that's what people were doing in order to kind of get their clusters support for network policy, which is kind of bonkers, really. Oh, and you can see here some of the. Oh, you're on mute, Marina.
Sorry, I actually wanted to walk through some of this in a second, but you're absolutely right. Like the reason we are here at this stage, especially with cloud native networking, is because of some of the learnings we did and some of the limitations we hit with the earlier CNIs like Calico and Flannel. And that's, like you said, that's why you saw combined offerings of Kennel. But then I think back in 2021, sorry, no, even before that, 2020, there was like an explosion of CNIs that came out. Like I remember Romana was there, Tanzu's Antrea was there. I mean, WeaveNet was still kicking around. All these different CNIs were offered. Even Cisco had their own CNI, if I'm not mistaken, through ACI, which in itself was a little bit very complicated because you needed the supervisor to kind of get in there and on it. Like I'm talking about like the ACI supervisor and control plane, which is heavy lift at that point. But that's another conversation that we could dig into, since now you're all part of the same family. So yeah. All right. So having said that, let's go back to the network policy editor and we'll come review some of those other network policy types in a second. So the next step is we want to allow traffic in the same namespace. So in our case, we obviously have workloads that may need to communicate amongst each other in the same namespace because they might be trading information or exchanging information of some sorts for an external workload. So let's go ahead and allow that. And when we go here, right? Oh, what changed here? I actually don't know what changed. Oh, I can't remove this. Dang it. So I think what ended up happening was the ingress from endpoints and the egress to endpoints was added just after that, which effectively allows all traffic in the same namespace. So if I have a pod in like namespace blue, pod A, and then have a pod B in namespace blue, that rule effectively allows them to communicate with each other either on the receiving end or on the sending end. So you could think of this as kind of a granular firewall of some sorts that gets applied at a pod level. I'm actually curious, do IP tables rules get applied right to the networking namespace of a pod? Or like rule sets? Because what I'm trying to think of or trying to draw the analogy towards is what NSX as a technology used to do and how it offered distributed firewalling right at the VNIC level, which is very, very similar to what potentially could be going on here.
Yeah, so these rules are going to be in either IP tables or NF tables, and they're going to be in the host namespace.
There we go. So it's in the host namespace. All right. So now that we've allowed traffic within the namespace, we're going to allow ingress traffic from specific pods in the same namespace. So we're going to, this is where the version comes in. So app equals front end version equals 2. App equals front end version. Ooh, did I do that right? Version equals 2. Okay. Version equals 2, 443, 80. From...
You got pod selector yet?
Yeah, so which one though?
From pod selector, because we're using those selectors.
Yeah, all right, there we go. Okay, so we're allowing ingress traffic from specific pods in the same namespace. So ingress traffic from front end version 2 to these ports. Okay, so that covers that. And then we want to allow egress traffic to specific pods in the same namespace. So same deal. We're just going to do the app equals front end and version equals 2. Version equals 2, and then 443, and then 80. Oh, interesting. So it added another 2 endpoint section. So why didn't it remove this previous one? Oh, Interesting. So let me ask you something, Dan. The rule evaluation here, shouldn't this go after this section here?
So your first rule is a block all, and then you're basically poking a hole in with the next rule afterwards.
Oh, okay. Yeah. So it's not read in like a firewall rule order. That's what it is. Yeah. Sorry, I keep tripping that up. Firewall's top to bottom. So what I would expect is this happens after you poke the hole through, because you're poking a whole bunch of holes, and then you have that catch-all at the very end that says if you haven't poked those holes, then you're not getting.
Yeah. So what we do actually is we put a blanket rule saying no endpoints, and then the next one we say here's a few endpoints now, and that's the poking the holes in the wall that you built with the first rule.
Awesome. Okay, so that's what we've achieved with this from endpoints and then the two endpoints. Love it. All right, so now we're going to allow egress traffic to specific pods in the same names. Oh no, we've already done that. Now we're going to allow incoming traffic from outside the cluster. So all traffic from outside the cluster is currently dropped, meaning if I made a curl request from anywhere outside towards any of my pod resources, wouldn't get through. So we have to allow that now. And what we need to do is ingress traffic from any endpoint outside the cluster will be dropped unless allowed by other rules. Advice: if pods in the namespace Star Wars need to receive ingress traffic, consider one of the following options. Allow ingress traffic from any endpoint only to specific pods. Allow ingress from any endpoint only to any pods, but only specific ports, like to port 80. Or allow ingress from any endpoint only to any pod in the Star Wars namespace. So we have three ways we can approach this. We can go directly to the pod, which is fine, but here's the other problem. If the pod disappears, right, then the rule isn't really valid anymore, because if the pod gets destroyed or someone deletes it, and another one comes on, does that policy still get applied to that same pod now? Assuming it has the same label, yes. And that's going to come from or be derived from what you do in the deployment side. But if we're just literally manually spinning up pods and expecting to deploy policies, this isn't going to work for us. Now, this actually might be a little bit better for us, because even if the pod changes, we're now inspecting on traffic towards port 80. So that gives us a little bit flexibility, a little bit more catch-all, except it's not as granular, because if we do have some pods that need to communicate with port 80, but other pods that we don't want communicating with port 80, this rule may not work for us either, right? So this is going to be entirely dependent on what workloads run within a namespace or across namespaces. And then this one is a little bit too wide open, because if I'm saying I'm going to allow anything from the outset to talk to anything inside my Star Wars namespace, I might be compromising all my workloads, right? What we're really doing here is we're just putting a policy in place. We're not really preventing something from doing something else. Like, once you're through the front door, you have free reign to do anything. And actually, this goes back to this element of role-based access control and even authorization, which I think we'll probably get to in maybe the next stream or the stream after, because it kind of leads us to some of the Cilium service mesh stuff in a way, and then maybe that creates our pivot point to talk a little bit more about that service mesh. So we're gonna choose from any endpoint, and we're gonna direct it to 443 and 80. And I'm only doing this policy because in production we would do something a lot more granular, a lot more specific to the types of workloads that we have. But for illustration's sake, here, this is what we're doing. So from the outside world, anything going to port 443 or port 80 is allowed.
If you want to pop to the Kubernetes network policy as well, just so you can kind of show what that looks like from that perspective. It's
interesting how it shows it as a CIDR block, because it's not able to hold on. So if we go back here, entities world, what is the definition of world? Like, where is that defined?
World. Yeah. So I mean, that's going to be a static thing inside Cilium itself, but it's effectively just going to be any IP address.
Yeah. So is world an actual resource in Cilium, or is that arbitrary right now? Like, I could change this to something else.
You should be able to change that probably to a CIDR.
Okay.
But
Okay.
I think world is basically just a word that is key matched to that side of block.
I see what you're saying. Okay.
Yeah.
I see what you're saying. So yeah, what we're seeing here, the CIDR block is a lot more specific in the sense that it's basically catching any IP, literally, from the outside world towards these ports. So that's what's going to be allowed altogether. Now, there's a few more policies we have to apply. Next, we're going to allow outgoing traffic from the cluster. So we want to allow traffic to endpoints outside of the cluster because at the moment it's currently dropped. Meaning, if I had a pod that needed to talk to an S3 endpoint, like a bucket for some reason that needed to maybe capture some pictures or some PDFs because you might be running an LLM locally or something like that, and you don't want to store stuff on premises, you want to store this in the cloud, that might be a reason why you would implement network policy there. So in this case, we're talking or referring to something in AWS. So here, all traffic to endpoints outside the cluster is currently dropped. Makes sense. You can allow egress traffic to the entire internet. However, we recommend allowing traffic only to known DNS names, known CIDRs, or specific port like 80 or 443. So we're going to allow egress traffic outside the cluster to certain ports. So if pods in the namespace Star Wars communicate with endpoints outside the cluster, consider one of the following options. Allow egress to specific CIDRs, so specific IP ranges or subnets, or to host names, because if we do CIDRs, the one thing that we aren't truly aware of is high availability considerations, right? FQDNs give us a lot more flexibility from that standpoint, not relying on IPs and static entries. So the fully qualified domain name or the DNS name is the way to go, in my opinion. And then allow egress to any endpoint outside of the cluster, which is dangerous in a lot of ways. Like, why would you do that? Why would you say, this pod can talk to anything? Because there's a real risk that you download a pod into your environment that is malicious, that has the potential to run as root, that has the potential to consume all resources in your cluster, creating effectively a denial of service attack in your production environment. So no, you wouldn't want to do that last one. You'd want to be specific. But just for fun, we probably could do it. No, we're going to lock it down to 443 and 80. And we're going to add that rule here. So where did that rule go? Okay. So going towards any destination here, this is the Kubernetes network policy, by the way, and specifically to ports 443 or 80, meaning if I had a pod resource that tried to SSH into something outside, would that work? No, it wouldn't work because port 22 is not there, right? So the more ports that I add, though, then I'm starting to allow more functionality. And I might have some custom ports that I'm trying to access. Anything you want to add there, Dan?
No, not really. I think, you kind of summed it up quite well that, if you don't know what's running inside your cluster, or people are deploying anything, here, there, and everywhere, quite easily spin up some sort of botnet thing inside your cluster. It's going to start trying to reach out to stuff. And the more that you can kind of block that behavior with simple stuff like this, then even if you get a botnet inside your cluster, it just won't work because it can't reach out to anything.
Yeah, exactly. So the next thing we'd want to do is we want to effectively create rules that only allow us to these domains or these FQDNs, Cilium.io and neopets.com. I don't even know if Neopets still is around. I don't know what happened to my Neopet. Maybe it's still alive. I haven't fed it in a long time. So we're talking like over 20 years now. So
yeah. I think it's worth pointing out before you click the add rule.
Sorry. Yeah, it's worth pointing out that I probably can't even have more than one.
No, I think it was the space between the comma. Was it?
Oh, really? Okay, maybe that. Let's see. No, only.
Just a single one per rule?
It could just be the network policy editor. It just doesn't support adding more than one, and it just might need to be updated on the back end. It just might be the UI.
That's worth pointing out, as well as it says at the top that this rule is unsupported. That's because it's a Cilium network policy only rule. So it will work. with Cilium. It won't work if you would apply it as it's not a Kubernetes network policy based rule.
Yeah, that makes sense. Yeah, because this is where we hit the constraints of Kubernetes network policy altogether. So interestingly enough, it doesn't even show up here. Yeah. So yeah, I don't see Cilium.io here. Now, on the other hand, if you really wanted to, I'm not saying you should, and also you shouldn't do this in production, but if you translated and did a DNS lookup of Cilium.io, you could probably just pop in the CIDR or the actual IP of where Cilium is. Now, let's be real. Cilium is just not one IP address. It's probably mapped to several, and effectively that wouldn't be the right tactic. So DNS is the right way to go, and this is effectively how you do this with the Cilium network policy, because it specifies here to match the specific DNS name and then specifically the ports. All right, so we're going to also allow traffic to egress to a specific CIDR, meaning a specific subnet. Now, in our case, we're going to just add a very generic subnet. We'll go 10.99.99.0/24, and we'll block 443 and 80. And all that really is saying to us is that anything destined towards this subnet is going to be blocked. And this might be because the subnet is either non-existent or it is used, it's classified. There might be a variety of circumstances in which you shouldn't be communicating with this subnet. We don't know why. I honestly just made up a random subnet, but we can see here the reflection of that. Now, what's interesting is this is supported in Kubernetes network policy right here.
Yep.
As we're witnessing. So what we're seeing here is DNS specifically, or host names, FQDNs aren't supported in the Kubernetes network policy, where they are supported in Cilium network policy. So looks like we can't do step 8. If your pod uses network-based liveness or readiness probes, then these probes happen via the network. Kubernetes requires that all network policy implementation automatically allow traffic from the host to the pod. Makes sense, right? I mean, the host itself, the node, needs to know what's going on with the workload at all times. And this is a management plane function. This is not a data plane function. We're not talking about pods trying to send like workload data to the Kubernetes API or the kubelet or anything of that nature. We're talking about how the pod actually gets run and the networking behind the scenes. So we don't have to do anything there. It's just implied in the policies. So we can go ahead and download this policy. And it even gives us instructions to try out with Minikube. And we can even deploy with Cilium. So we don't even have to go like that extra step. But I don't even think I have Minikube on my MacBook. But let's take a look at the policy. Let's see if we can. I'm going to try and open it on my local system. Copy path. And then I'm going to go over here. Dang it. I just want to open it. I don't want to download it. Okay. Never mind. I will share my screen again, and I will just show y'all. So that's the resulting network policy in all its glory. Like, we went from just having a very simple few lines, I think it was 10 lines of a network policy that wasn't doing anything. And then we proceeded to add in ingress. Oh shit, I'm not sharing my screen.
No.
I just realized something. Yeah. Always fun. Always a fun time. Can you see it now? Can you see it now? No, it's not
yet.
The browser can't access your screen. That's always fun. You know what? Let me see if I can paste this into Git or like a gist or something like that. And then maybe Dan, if you want to maybe share some thoughts about some of what we were up to while I find a way to.
Yeah, sure. I mean, I think it's kind of clear between the two types of network policy that kind of exist. That the Kubernetes network policy is largely built upon what's capable with technologies like IP tables. So effectively being able to base your effectively firewall rules on things like IP addresses, source addresses, destination addresses, ports, and things like that. Whereas with the Cilium network policy, you started to see things like being DNS aware, being able to determine, destinations based upon address filters. You can start to see that we can do a lot more because we can see inside the actual application itself and things like that. Marino had a page up as well, which actually talked about some of the other application-specific filters. So one being Kafka and the other one being HTTP. All of these, are powered by eBPF basically. So that, using that, we can start to have a lot more control about what's actually happening based upon behaviors of application.
Exactly. So I did pull up the policy. I have it in another tab, and I'll share that in a moment. But in the meantime, let's just take a look at the different kinds of policies that you can create inside of Cilium. So we saw basically the layer 3 and the layer 4 examples. There are so many more details and so many different types of examples that you can create. Layer 3, we specifically tie it to just host name and even IP insider information, whereas with layer 4, we get to be very specific with the port types and protocols. So we saw some of that, like we're able to specify 443 and 80 as ports and even DNS ports as well. But if you notice here, there's layer 7, right? There's layer 7 examples where we're now policing traffic based off of potential header information, based off of what we're doing from an authorization standpoint. While this is, really more about filtration, layer 3 and 4, layer 7 is more about what can you do once you've gotten past that front door, and that's important. This is something Service Mesh typically does handle, but given the fact that you have Cilium already deployed in your environments, I mean, it's not so much more work to turn on this Service Mesh-like functionality and enable layer 7 policy. There are other policies. There's deny policies, the host policies. Tell us a little bit about the host policies, Dan.
Yeah, so I think off the top of my head, from how I understand it, host policies are a lot more control into the actual host itself. So it tends to behave a little bit more like a firewall outside of, for the node itself. Yeah.
For a cluster. Yeah. So this is where Cilium gets interesting, because it's not only in providing security and firewalling or like policy for workloads inside of your cluster, but also for your cluster too, which is actually an interesting problem, because most of the time we don't think about securing the control plane. We think about securing the workloads where our control plane is effectively running, or the control plane drives. But then when it comes to what happens and who defends and who watches over the control plane, there you go, right?
100%, yeah. I mean, if you look at a lot of the stand-up guides for setting up your Kubernetes cluster on things like Ubuntu, it's like step 1, disable firewall D. It's like, right, so there's no firewall on any of these nodes. And then I stand up my Kubernetes cluster, but like I've disabled kind of like a key security feature pretty much out of the gate.
That's awesome. All right. So I did share a link to the network policy YAML that we constructed earlier, so y'all can take a look at it. There are some other network policy stuff here. We'll come back and revisit that in a future stream. But let's take a quick look at the output of that network policy. So I dumped it into a YAML file, uploaded it to GitHub, and Michael's probably like, why didn't you do this on GitLab instead? We're working on that. Akancha's working on that. So we'll get there. But shout out to Michael and all the stuff he's been doing from a GitLab standpoint. But you can see like the network policy in its granularity, the destinations that we're going to, the FQDNs, what we're blocking versus what we're allowing. So go inspect this, right? Like I could probably take this, drop it into ChatGPT and say, comment every single line, and it'll tell me exactly what's going on. I recommend you all do the same so that you can dissect network policy as a whole and understand where you can start going with it, especially if you're using this in production. Or you know what? Talk to Dan. Dan will take you to production if you want.
I'm here.
All right.
I'm here, ready and waiting. I think, I mean, that's kind of the thing I think that's very cool about Network Policy Editor is you know, like if somebody gave me that YAML and asked me to actually describe what it did, you know, like it's a load of YAML, and I'd get there in the end. I can upload that into network policy, and all of a sudden boxes will appear, and red and green lines will immediately visualize everything.
I didn't
And all
know.
of a sudden,
I didn't know you could do that. You could do the opposite. You could actually upload a policy,
yeah, I
and it'll
believe so.
visual. Oh
Flows
wow.
upload.
Okay, I didn't know that. Oh yeah, there. Oh, you actually need Hubble flows. So maybe we should look at that next week.
Yeah.
That'd be cool. Let's look at Hubble and see how we can generate a network policy through that and upload this into network policy editor. Done. All right, we're going. We're doing this.
Yeah, there's
cool.
an upload policy button on the left-hand side of the thing.
Yeah, I'm looking at it now.
Yeah.
But I don't have the data to upload, so
That's fine. But yeah, like I mean, if you're wanting to actually understand what your policies are actually doing from a visual perspective, you can basically upload that, and it just all of a sudden will visualize it. You'll have all the lines, you'll have the architecture of it all, and things like that.
Yep.
And I think one final thought, really, of people who are studying for things like the CKA and the CKAD and things like that, this is just an amazing free resource to learn, to deploy, and to understand what your policies are doing.
I've just shared the link, editor.networkpolicy.io in the chat. All right. Well, that was a good stream. It brought us right to the end. Things look like they were working. We never tested out the policy though, so I really don't know if it works. But maybe we'll do the opposite next week, where we're using Hubble to generate that policy, and then we'll test it out on an environment. But I just want to say thank you all for coming by again. Dan, Leon, Akansha, thank you for coming out, hanging out, making this a fun conversation and live stream. And for everyone watching, thank you again. We will see you all next week. Have a great week. Have a great day. It's Monday. Go enjoy yourselves. Go make some magic happen. See y'all.